Welcome, 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 year 11/12 to exercise 3D, where we're going to solve some inequations. Now, when we're talking about f of x is less than g of x, that means where is f of x below g of x on the graph? We can add anything and subtract anything from both sides of an inequation. We can multiply and divide, but if we do, if it's negative, the inequality symbol is switched. Can't multiply or divide by 0. Denominators can be multiplied to the other side by squaring it. That way, if it's negative, it doesn't matter because when you square something, it's always positive. And we'll go from there. And we can use tables of signs, sign derivatives, if we want to help us. Let's try our first example. Now, the first example says, solve thou inequality by multiplying through by the square of the denominator. So let's actually do that. Let's multiply by x take 5 squared to both sides. Now, if I multiply by x take 5 squared, the x take 5 on the bottom cancels with one of them from the x take 5 squared, which leaves me with 2. X take 5 is greater than or equal to minus 1 x take 5 squared. That gives me 2x take 10 is greater than or equal to, now x squared, but I've got a minus in front of it, minus 10x, but the minus makes that a plus 10x, plus 25, but the minus 1 will make that a minus 25 when I expand it all out. Let's move everything over to the left-hand side, and that leaves me with x squared minus 10x plus 2x becomes minus 8x. Minus 10 plus 25 becomes plus 15. That can be factorized. I know two numbers at times to give 15 and add to give minus 8 are x minus 3. So I want minus 3 and minus 5. If I draw a parabola representing this, because I've got a quadratic and it's a parabola. If I draw my parabola, it goes through the x-axis at 3 and at 5. Which bits am I interested in? I'm interested in the bits above because it says greater than 0. So where is it above? It's above to the left of 3 and to the right of 5, and it also includes it because it says greater than or equal to. So there's my solution for part A. Now part B says use a sketch of y equals 1 plus 2 on x take 5 to solve 2 on x take 5 is greater than or equal to minus 1. Well, let's look at this. What is the graph of y equals 1 on 2 over x plus 5? Well, I know that y equals 1 over x is a hyperbola. Y equals 2 over x is a hyperbola. This is a hyperbola, but the hyperbola is pushed up 1. So I'm going to have a hyperbola. All hyperbolas have asymptotes. I'm going to be pushed up 1. So I have a horizontal asymptote, that's y equals 1. How did I know that? Because it was pushed up 1. If I look at the denominator, x take 5, x can't equal 5. So I have a vertical asymptote at x equals 5. Now I know hyperbolas, when they're positive, go this sort of a shape. I'm guessing a bit here. I could find x and y intercepts. To find an x-intercept, let y equals 0. So if I let y equals 0, I'm going to get minus 1 to both sides times the x take 5 to the minus 1, which gives minus x plus 5 equals 2. Rearrange that, I get x equals 3, which means that's at 3. To find a y-intercept, I'll let x equals 0, you get 1 plus 2 over 0 take 5, which becomes 1 minus 2/5, which is 3/5. So that's where it goes through the x-axis and the y-axis, so that's okay. Now, how am I going to use this sketch to solve this question here? Well, if I look at this question here, this question, if I rearrange it, says 2 over x take 5 plus 1 is greater than or equal to 0. Now, I just graphed 2 on x take 5 plus 1. That's what I graphed. That's what this green graph is. It's that graph there. So, by saying 2 over x take 5 plus 1 is greater than or equal to 0, what we're saying is, where is my green graph greater than or equal to 0? Where is it above or touching the x-axis? Well, it's above or touching the x-axis, whoops, there and there. So that's going to give me my answer. So my answer is x is to the left of and includes 3, or x is to the right of but does not include 5, because 5 is an asymptote. So that's to the left of 3, and that's to the right of 5, but not including 5. So that is my solution from the sketch. Now, that's interesting, isn't it? Because when I look at my answer to part A, it's actually pointing out that I didn't get part A right. Because this question here and this question here are the same. Now, I was a little bit careless on this one here, and we need to discuss why that mistake was made. So the maths is correct, but when I get down to the bottom here, I need to be careful, because when I look at the original question, x can't equal 5, or I get 5 on the bottom of the fraction, which means 5 is not valid, and that needs to be just greater than, not greater than or equal to. And now this answer and this answer are the same, because those questions are the same. Time to continue. Now, let's just do a recap a little bit on absolute value. When we're talking about absolute value, if I said the absolute value of 3, that actually represents how far, or how many spots can you be 3 units away from the origin. So minus 3 and plus 3 on the number line are 3 units away from the origin, and that's fine. But if I have something like, well, actually, let's leave it at that. We can extend that concept further, and I'll do that later. Let's get into our example. First of all, question 2 says, solve the following. Well, there's 3 questions, and they're actually the same question when you look at it, but one has equals, one has a less than, one has a greater than. So, once we get the answer to part A, we might be able to use some of that information to help us with parts B and part C. Well, equal sign questions are the easiest ones, and we're going to do this twice. We're going to do it once for the positive case and once for the negative case. So for part A, the positive case will give me 26 minus x squared equals 10. If I plus x squared to get it over to the other side, and minus 10 brings it back there, so x is going to equal plus or minus the square root of 16, which is 4. Let's look at the negative case. Well, the absolute value will become negative 26 plus x squared equals 10, which means x squared equals 36, so x equals plus or minus 6. And there's my solution for part A. Well, let's go to part B. Part B, a little bit interesting, but we're going to use a concept here, and the concept is that when we're looking at something, when we were looking at, let me just write this, when we were looking at our when we were looking at our absolute value, x, the absolute value of x was how far you were away from 0. So the absolute value of 3 Could be at -3 or +3 because you're 3 units from 0. But if I had the absolute value of x is less than 3, that means how often are you a distance that's less than 3 units from 0, which is anywhere from there to there and anywhere from there to there. Anywhere between -3 and 3, pick any point there and you are less than 3 units away from 0. So we're going to use that same concept, but we could rewrite that by saying x is less than 3 but bigger than -3, because that's anywhere less than 3 units away. So let's get back and start the question. So I'll just clear that off. Don't want to go too far. So what we're going to say for this particular question is 26 take x squared must be less than 10 and bigger than -10, because between -10 and 10 are all the values that are less than 10 units away from the origin, or from our number. Now, if I look at this, I'm going to -26 to all three sides. So -26 will give me -36 is less than -x squared is less than 10 take 26 is -16. Now I'm going to multiply everything by -1. Gives me 36. I have to switch the sign. Which means I need to rewrite this as 16. I need to have my arrows pointing to the left when they're combined, so that's a better way to write it. This is where I need to be careful. There's actually two answers for this one. There's going to be the square root of 16 is 4, the square root of 36 is 6, so x is going to be less than 6 and less than or greater than 4. That's one solution. But if you took the negative situation, you're going to get x is less than -4 and bigger than -6. Because it's around the other way. It's a bit weird, but you've got to do the negative case, and when you're doing the negative case, -6 is smaller than -4, and you can plug values in to check them, and that will hold true. Now, for our last case, when we're talking about, and I'll just do a case here, if I talked about the absolute value of x was greater than 10, there's 0, there's 10, there's -10. That's talking about all the numbers that are more than 10 units away. So that's going to be out there and out there. So that's what I'm looking for in this case, values that are further away. So let's see how we can set this question up. So we say 26 take x squared. Excuse me. We're going to say 26 take x squared is greater than 10, or 26 take x squared is to the left of -10. I've got to do it as two separate questions because when you actually think about it, they don't come in contact with each other, so they're two separate questions. This one here, if I rearrange it, -10 to both sides and plus x squared to both sides, so you get x squared is less than 16, and on this one here I'm going to plus x squared, so I'll get 36 is less than x squared, or x squared is greater than 36. Now what numbers provide x squared being greater than 36? Well, all numbers bigger than 6 and all numbers less than -6, because -7 squared, -8 squared gives answers bigger than 36. Now, what numbers, when you square them, give answers less than 16? Well, x is going to have to be numbers smaller than 4 and bigger than -4. And that's your solution. So for this one, if I write it in a different colour, they're all the possible solutions in amongst that. So you need to try some of these questions, see how you go, and as always, enjoy. Bye for now.